input is 1, 1. Random weights assigned at the beginning of the algorithm is 0.8, 0.4, 0.3, 0.2, 0.9 and 0.5. Input is 1 and 1. Random weights assigned at the beginning of the algorithm is 0.8, 0.1, 0.4, 0.3, 0.2, 0.9 and 0.5. Got it, all of you? Shall we start the calculation? Then we'll calculate the Z. What is Z? Input n into weight n. Sigma input n into weight n. So is equal to 1 into 0.8 plus 1 into 0.2. Okay. But 1 is equal to 1 into 0.4 plus 1 into 0.9. .3 is equal to 1 into 0.3 0.8. So 1 into 0.8 plus 1 into 0.2, 1 into 0.4 plus 1 into 0.9, 1 into 0.3 plus 1 into 0.5. One into 0.5. Got it, all of you? So input into weight. 1 into 0.8 plus 1 into 0.2, 1 into 0.4 plus 1 into 0.9, then 1 into 0.3 plus 1 into 0.5, right? Input into weight. Right? Then sigmoid activation. What is the formula? 1 divided by 1 plus exp open bracket minus z. 1 into weight. What is 1 into 0.8 plus 1 into 0.2. 1 into 0.4 plus 1 into 0.9. 1 into 0.3 plus 1 into 0.5. Input into weights. Sigmoid activation is equal to 1 divided by open bracket 1 plus exponential open bracket minus select the 1 value. 1 divided by 1 plus exp open bracket minus and then select the 1 value. So you get 0.7. You can track the formula down to. This is the formula. All right. Random output weights. What are the random output weights? 0.3, 0.5, and 0.9. These were assigned at the beginning of the algorithm. So these 6 weights and these 3 weights are assigned at the beginning of the algorithm. Okay. Now sum product 0.731059 into 0.3 plus 0.7858 into 0.5 plus 0.6899 into 0.9. Sigmoid into weight plus sigmoid into weight plus sigmoid into weight. 0.73105 into 0.3 plus 0.7858 into 0.5 plus 0.68997 into 0.9. Sum product. We will get it as 1.233212. Now we will activate the sigmoid activation. Sigmoid activation is equal to 1 divided by 1 plus exp open bracket minus this. This is sum product. Zero point 0.731058 into 0.3 plus 0.7858 into 0.5 plus 0.68997 into 0.9. Sigmoid into weight plus sigmoid into weight plus sigmoid into weight. We get 1.233212. Then do the sigmoid activation. Sigmoid activation is same 1 by 1 plus exp to the power of minus the value. Right? This is what? Predicted probability. And what was the classification rule? Probability greater than or equal to 0.50 will be classified as 1. Probability less than 0.50 will be classified as 0. What is the actual output? Actual output is 0. What is the predicted output? It is 1. Predicted output is 1. The actual output is 0. The predicted output is 1. Got it, all of you? So actual output is 0, but our predicted output is 1. Then from this part, it will start the backward propagation. Okay. So what is the first step in backward propagation? Calculate the error. Yes. Okay, all of you done till this point? All right. So after error, derivative sigmoid, which is sigmoid of x multiplied by 1 minus sigmoid of x. Which is equal to 0.77438 into 1 minus 0.77438. After calculating the error, we calculate the derivative sigmoid. Derivative sigmoid is sigmoid of x multiplied by 1 minus sigmoid of x. To get minus 0.77475. All of you got this? Yeah. Then you multiply error. Multiply error with derivative sigmoid. Okay. Here it is there, sigmoid of x multiplied by 1 minus sigmoid of x. Multiply error with sigmoid x. derivative sigmoid. Multiply the error with derivative sigmoid. That means is equal to minus this into this.
Sigmoid activation formula.
0.77 into 1 minus 0.7743. Then you multiply the error is equal to error multiplied by derivative. You get minus 0.1353. Right? Now divide column K value with column D values. Column D, that means is equal to minus 0.1353, fix it by pressing F4 divided by 0.73. Divide minus 0.13. 1353 numerator you have to fix by pressing F4 or Fn plus F4. Then you can drag the formula down. These are the three values. Minus 0.1353 divided by 0.7310 minus 0.1353 divided by 0.78 minus 0.1353 divided by 0.6899. Or you can do manual also.
Round of this round of this.
Expanded value కావాలంటే same thing. Divide 0.1353 minus 0.1353 with 7310 with 0.7858 and also with 0.6899. Got it, all of you? Yeah. So what are these? Delta output weights. That means we have to deduct them, right? So the new output weights. These are already negative numbers, so we will add them because we are trying to reduce them, right? These are negative values, right? So add them. 0.3 plus 0.18. This is a negative value, so I'm adding it. If you put minus, it will add it. But we are trying to reduce the weight, right? Our job is to try to reduce the weight. So 0.3 minus 0.18507. You get 0.114931 and you drag it down. These are the three new output weights. These are the new three output weights which are generated from the subtraction of, or in this case, addition 0.50 with the version 0.3 minus 0.18507 with solid negative number. So you have to put plus sign. 0.3 plus minus 0.18507, 0.5 plus minus 0.17217, 0.9 plus minus 0.1969. You will get the new output weights. The new output weights you will get. I am adding because they are already negative numbers. If you put minus 10, it will add to the weight. It will not reduce the weight. But what we are trying to do here, we are trying to reduce the weights. Our agenda is to reduce the weights. So we are deducting 0.3 plus minus 0.857. Right? You will get the new weights as these. These are the new weights. Got it? Next step is we have to correct the input weights. We have to start correcting the input weights. Divide column K with what? No, we can't, because the calculation formulas, we have to copy paste the formula and redo the iterations, right? You can't have any gaps in between. Column E. We have to divide column K with column E, which means is equal to this. Fix it by pressing F4 divided by this. Column K, these values you are dividing with these values. Got it? Multiply column N with hidden derivative sigmoid. Hidden derivative sigmoid. See, you have to multiply with hidden derivative sigmoid. Hidden derivative sigmoids are in column D. In my case, this is the hidden sigmoids, right? So is equal to this multiplied by open bracket 0.7357 into open bracket 1 minus 0.53107. Multiply column N with derivative of hidden sigmoid. So you get minus 0.8867. You drag the formula down, you'll get the same values, right? Now is equal to select the first value and enter and drag it 2 cells down. Don't paste them. is equal to, select the first value again, because the input is same, right? Divided by 1 is, you'll get the same values. Is equal to, select the first value, drag it. See, all the formulas should be interconnected because we are going to do iteration. Second iteration, we'll check with this new way whether it has worked or not. Is equal to 0.6, and then you drag it down so that you can have the formula interconnected. See, this is 0.7. This is 0.8. Okay. Don't copy paste. Is equal to and connect the cell. Now, what we have to do? These are the delta input weights, right? New input weights. New input weights. How will you calculate? Select the previous first cell and then drag it down because interconnection of cells is needed here. So the new input weight would be 0.8 plus the delta weight. You add it to the, you add this delta input weights. To the original input weights, you will get the new input weights. These are the new input weights. Original before, where you have random assigned weights, no? That you add the cells. Random assigned weights. Got it, all of you? All the calculations? Save the sheet. All of you save the sheet. Okay. Now, all of you just focus on the projective ones. I am selecting the whole calculation using the shift and arrow. I am selecting the complete calculation using shift and arrow, Control C. Okay. Scroll down. Give one cell, one row gap. Go to paste special, formulas and number formatting. In paste special, you have formulas and number formatting. Paste it as formulas and number formatting. Save it. Now, what I will do is, I will go to the previous calculation, copy the new output weights, and in the second iteration, I will replace them. When you're pasting them, paste values and number formatting because they're formulated cells. You can't do Control C and Control V. You have to paste them as values and number formatting. Similarly, I'll go to the previous calculation and copy the new input weights, Control C, come to the second iteration, and I will select the cell, paste special values and number format, and Control S. Now, what is the predicted probability here? 0.69. It came down from 0.77 to 0.69. And it has already calculated new output weights. See, these are the new output weights which are calculated in iteration 2 and the new input weights calculated in the iteration 2. It automatically calculates these things. So go back to the iteration 2, use shift and down arrow, select the complete calculation, Control C, and then give one row gap, paste special formulas and number formatting, Control S. So I'll go back to the previous calculation, select the new output weights, Control C, and I'll paste them in the here, paste values and number formatting. I'll go back to the previous calculation. I will select the new input weights, Control C, come to this calculation, select it, paste values and number formatting. Now the error came down to 0.59. So maybe in the next iteration, it should come to our targeted range. So I'll copy the formula again. Then select a paste special numbers and formulas and number formatting. Then go back, Control S, go back to the previous calculation, get the new output weights, replace them with the numbers and values and everything, and go back to the previous calculation. We'll get the new input weights, Control C, and I will paste them in place of here. Paste values and number format. So now we got our predicted probability, predicted output is 0. Right? So in how many iterations we did? 1, 2, 3, and in 4th iteration, it automatically corrected to the level we want. This is how the iterations will be run for each row. So this is a complex calculation which you need. So select the complete calculation, paste it as formulas and number formatting. Go to the previous calculation, select the output weights first. So paste them as values and number formatting. Again, input weights, paste them as values and number formatting. You will get the calculation. Second iteration. Huh? These are the weights for the second iteration. New output weights, new output weights and new input weights. First, copy new output weights and place them in place of random weights assigned output.
ఇది లాస్ట్ చూసుకో అదే మన మళ్ళీ ర్యాండమ్ జీరో వచ్చేసింది అంటే కానీ ఇక్కడ ఈ ఫార్మల్ ఏం మారలేదు అప్పుడు మన సెకండ్స్ పెట్టుకోవాలి
Guys, SQL, you have to practice constantly, right? Keep things, SQL questions and all. I'm also will connect a test on SQL. Whatever we have learned in SQL, where statement, when to use where statement, when to use having, you know, right? Having, like, right? Duplicate, how to identify duplicate things. What is the difference between what to call inner join and outer join, or left join and right join, right? So these are the constant questions we are seeing. And how do you do drop or alter the data table? What is the drop command? You have to by heart those commands. Drop table will permanently delete. Alter table, that's what math company SQL questions. And second thing is, you have to do a cloud certification, which is, I didn't tell you guys till now, but math companies and even Capgemini asking that one. The easy certification is Azure DP100. It costs you 4,000 rupees for doing the certification exam or complete the course. It's an online free course. That's what they're saying. Math company, they asked him all questions on ETLs, pipelines, and all. So this is this thing. The Indian, you can go to Pearson View and write the test once you have completed the modules. The exam fee is 4,800. And yeah, so online is free. Online is free, right? So you can do create machine learning models, AI fundamentals, build, operate machine learning with Azure, build and operate solutions with Azure Databricks. So you can see these are the modules. You can go through them one by one. There are a lot of videos online in YouTube for this thing, DP100. Mock exams are also available online for DP100. Please start working on this. This will increase your CTC by 2 to 3 lakhs. It will increase the CTC by 2 lakhs. That's what they asked him. If you have any certification of Azure, GCP, and AWS, any one certification if you have, or if you can do 2 certifications, 3 lakhs is your CTC that goes up. Same Capgemini, which is offering 3,200, 3,20,000 CTC, will offer you 6.5 lakh CTC. If you have 2 out of 3, or 5.5 CTC if you have 1 certification at least. So this is the easy one, DP100, and most of it is Python only, which you have learned, NumPy, Pandas, and all. Right? Explore and data with Pandas, right? Regression models, train and evaluate, classification models, clustering models, and deep learning models we will cover in next 2 weeks. So, and then you have your little bit of complexity might come in this module, Azure Databricks. I will try to do this. This is one. That is the workbench. Databricks is the what you call, it's like workbench. Like you have MySQL workbench, right? Similarly, Databricks is the workbench for Azure, where you can build pipelines, data pipelines, pass them through models, preparing data for machine learning. There is no code. See, for this, so for this also there is no code. See, actually they just need to, you need to remember these, how to go through that location, how to set up those what you call machine learning flow models, how to run experiments. These are the theoretical things. See, it's all, you have to go to experiment and then you have to create an experiment. They give you this step by step. Just go through module by module. You will understand what it is, and then these are very simple things, not complicated, no programming, nothing. Simple MCQ questions, and you can do the test, right? So please focus on this. This is the easy one. Azure DP100. So this is one. I think I have not given you, right? See, data engineering, there are a lot of jobs. They are now very. Okay, I will send you that Azure DP100. Then GCP, Google also has. Collaborator is only this one, what you call. So Google is a little bit complicated. This is the learning paths you can see here. So learning paths here, data engineering and analytics. So this is the thing. 4 courses, 4 labs, 40 hours. You can learn the, again, online course is free. For badges and certification, you have to write an exam. GCP. Yeah, sent one, right? All of you got it? What happened? Why it is not going? Internet problem, huh? Uchinda? Uchinda kada? But why it is not showing in my system? GCP Professional ML, right? The course name is Data Engineering and Analytics. All right. So please use your time on these certifications, which are important, right? Get started for free. Examination, you have to pay the fee. Okay. You can create a GCP account free of cost, and then you can work on it. Or you can find Data Engineering and Analytics GCP course on YouTube also. YouTube also has it. Let me check. See here. So this is the free only. You can look at the GCP certifications. The modules which are required, these guys are providing free. Data engineer, cloud professional data engineer. Even Azure DP100 also. Okay. See, a lot of workshops are there. Exam preparation videos are there here. Use these materials and you can first go through the online material, which is free. There are a lot of people are doing this. I am asking all my students to do Azure DP100. It will give you at least 2 lakhs on CTC, base CTC. Okay, just invest your time and then do. So what happened is multiple machines. This is why one machine machine. So use these videos and so you just need to remember these processes, that's all. There is no coding involved here. Everything is predetermined things. All you need to do is you need to use those predefined functions and commit things. So you can do this. Free videos are there for all the exam. Do these things. That would be the best option. See, you will get a job, but that thing which you want, higher CTCs, like what a lot of PJ18 guys are trying to get higher CTCs. Then you have to have this certification exam, these certifications. Any one of them is needed. If you can do two, you'll have huge opportunity. Okay, so please work on it. In the next weeks, we'll work anyway. Deep learning and clustering techniques also I'll cover. You can also, by that time, you can fully prepare, look at the videos, go step by step, prepare your notes, attend for every module, there is mock test available online, free of cost. You can test the mock test. There also you have mock test for DP100, and then you can use them. Okay. So first is DP100, which is easy to clear, then go for GCP, which is a little bit tough. You need to have Hadoop also. Maybe by the time you come to GCP, I will only teach Hadoop for PySpark. Maybe in the month of May first week or April last week, we'll start with PySpark. Python Spark, Apache Spark, machine learning. Okay, so please do that, and also SQL profile. Create an exclusive SQL profile. The movies data, which I have given you, right? You would put SQL into GitHub, and then you can practice in another data set called New York Times bestseller books. Books data set is also there. That is a JSON file. You can import the JSON file into your SQL environment and do queries. 20 to 30 queries you can do. If you want to what all queries you want, I will send you the questions. You have to query those 20 to 30 or at least 30 queries, covering joins, everything, where, having, like, your what you call, and conditional statements and all. So put a GitHub profile with resume focusing on SQL. Okay, and then SQL with different. We all know server SQL as well as MySQL. The two types of SQL we have learned, right? MySQL I taught. Server SQL somebody else is taught. You can do the same movies database in server SQL. Not much of a difference, right? I'll try to send the server SQL. Some PG18 guys have done it. If once I get it from them, I'll send it to you. The server management SQL or server SQL, Microsoft SQL server. In table only you'll find everything. Or there is a Google data search. There is a Google search for data. Because of data science demand, you have exclusive Google data search. No, JSON file. Look for the JSON file. CSV file is partial data. So Google dataset search is there. So New York Times bestsellers. This is books data. So it's a zip file. The data contains here bestsellers from 2010 to 2019. Each week, 5 books are named as bestseller for each category. Okay, and you can see it, explore the data in Kaggle. Go to the Kaggle and download the zip file. I think this is a JSON file only. 10 years later, this is also very large. CSV is coming on. 17.84 MB. But JSON file is also there, but 2008 to 2008. That's what. JSON file, see, you can download many of them. 2011 to 18 is there, na? CSV zip is there. You can use any of these New York Times bestsellers. And constantly, every day, 1 hour theory. I have given all the PDF files. You all mobile phones have Acrobat PDF reader, right? You can have that application. You can open those PDF files which I have sent to you on your mobile and read the notes in the PDF files. Whenever I send a PDF file along with IPNB notebook, there is notes in that PDF file. Read that notes. Again, same issue is coming up with some of the PGA 18 guys. They are not able to answer certain conceptual questions. You should not be like that. You should be able to clearly explain the conceptual answers also. Right? Please focus on theory also. So these calculations, all of you have done the Excel calculation. So this is how the neural networks work on the base. This is how the simplified calculation which you can do. But when you are dealing with large scale data in collaboratories or GPUs and all, certain different methodologies are used. Matrix factorization models, all are used. Matrix factorization is again a derivative calculus model only, which will deal with large scale matrices. Right? And most of this data will be in matrix form. So you will implement MLP classifier, or shall we do an image processing data example? What do you guys want me to do? You want me to do it on any existing data, or you will implement MLP classifier? Because you know, right? Dot fit, dot score, same process. Only thing is you have to define the hidden layer sizes. Or you want to use Google Collaboratory and do a multinomial problem. What do you want? Multinomial you want to do on Google Collaboratory, GPUs? Okay, I'll send you the notes and all. See, implementing in Python is just like your normal thing. Only thing is you have to give additional arguments like hidden layer sizes. Neural network MLP classifier, you will give your hidden layer sizes, how many layers you want. You can run it on that. I'll show it. That's not a problem. Any Jupyter notebook, you can do it. Or we can do a basic, or let us do a basic model on Google Colab also. See, one important thing you always need to remember is the activation functions are very important. The activation functions are important. The optimizer or the solver is important. The solver or the optimizer. In Python, we call it as solver, whereas in deep learning, we call it as optimizer. Your solver optimizer is important. And how many layers and how many neurons per layer is also very important. There is no fixed formula to define how many layers and how many neurons. It's all based on your trial and error method. But there are two rules. The first layer, which you are giving as input, the first layer should have neurons greater than your inputs. The first layer should have neurons greater than your inputs. And the last layer, the activation function will depend on the problem you are doing. If you are doing a regression problem, it is linear. Activation is equal to linear. If you are predicting a binary, activation is equal to sigmoid, the last layer. If you are doing multinomial, activation is equal to softmax for multinomial predictions. So these are very important things which you need to do. A lot of tuning parameters, hyper tuning parameters are there in neural networks. Lot of hyperparameter tuning. You have to tune them properly. Otherwise, it will show you wrong outputs. So Kaggle house price prediction, you all have this notebook, right? Open this notebook and run all the cells. While it is running, let me talk about hyperparameter tuning for neural networks. All of you can see the font size, or you want me to increase a little bit? Is okay? So the first thing is activation functions. You need to define your activation function for each hidden layer. For each hidden layer, activation function must be defined. For each hidden layer, you need to have activation function. Similarly, neurons. You also have to define number of neurons for each hidden layer. For each hidden layer, you also have to define the neurons. Again, it's trial and error method. There are no fixed formulas. You have to go with trial and error method. Then, the first layer must have neurons greater than your input variables or independent variables. The number of neurons must be greater than your input or independent variables, and input shape also must be defined. Input shape must be defined. I'll tell you what is this input shape, how we have to define the input shape. For the last layer, the activation function depends on the dependent variable. The dependent variable class or levels. It can be for regression, it is identity or linear. For classification, if it is binary, it is sigmoid. And for classification, if it is multinomial, you have to use softmax. Which one? See, the initial hyperparameter tuning you have to do first. Then, if you are satisfied with the model, you stay there. Otherwise, you have to rework your activation functions. You have to rework your thing. There are some algorithms called grid search algorithms. In Python, we have these grid search algorithms. In grid search algorithms, you can give multiple hyperparameters. You can give multiple hyperparameters and different combinations. So this grid search algorithm will run all the combinations and whatever you are doing, and it will find the best fit model. It will find the best fit model parameters. Now, the problem with this grid search algorithm is they require computing power and they require a lot of time. So let us say one hyperparameter can go given grid search is hidden layers is equal to 2 hidden layers, comma 3 hidden layers, comma 5 hidden layers, and comma 10 layers. So it is model build with one model with 2 hidden layers with an activation function with a predefined neurons and a predefined input and y. Then it will build another 3-layer network with activation, inputs, and y. It will build a 5-layer network and then compares all the outputs and gives you the best possible layer network. But these grid search algorithms require computing power and they require time. They will run for hours. They will run for hours on GPUs. On CPUs, your system will crash. Never run grid search on CPUs. It will crash the system. You have to run grid search on GPUs, either in Google Collaboratory or Kaggle. And it will take 1 hour, 2 hours, sometimes it will take 3 hours to find the best set of parameters. So a lot of people, instead of using grid search, they manually give trial and error experiments. They constantly change the values and then I'll show you how to do that. Then you also need to play with learning rate. Rate at which the weights are adjusted. This is also very important. For large scale models, learning rate should be as smaller as possible. Similarly, for independent variables, what we should do must be either scaled or normalized. Either you have to scale the data or you have to normalize the data. In image processing, we do normalization. This also has to be done. Similarly, the solver or the optimizer is also very important. And most used is Adam because it runs very well on large data. Adam and SDD, large data, they run very well. They are very fast, they run very, very well. You also have to define a loss function. Loss function is RMSE. In regression, we have RMSE, right? Here, we have what we call loss function can be binary underscore cross entropy, categorical underscore cross entropy, classification, RMSE for regression. So yeah, loss function also has to be defined when you're dealing with large scale networks. And you also have to look at iterations. Iterations for self-correction. You have to look at the iterations. Max iteration is 200. Sometimes you have to increase iterations to 500. Your accuracy will improve because it will have more time to learn, right? But again, time consuming. Time consuming is the problem. Hello? Yeah? ना अभी नहीं चाहिए. Okay, so these are the popular hyperparameter tunings which you have to do for neural networks. It is part of model. I will show you. I will explain what it is. All of you have run the notebook? All of you have run the notebook? Okay. From sklearn dot neural network import MLP regressor. So MLP regressor multi-layer neural. Okay, so MLP regressor, the hidden layers of 100. Activation is ReLU, solver is equal to Adam. Batch size auto, learning rate, max iterations, everything is there. Activation is equal to identity, is for linear. Activation is equal to identity. So we will first make only one change and run it. NN is equal to MLP regressor, open bracket, hidden underscore layer underscore sizes. Now, what was our input size? I think 79, right? Our input size is 79 variables, right? Remember? 79, 43, no, 81, and then we delete, no? We deleted sale price and ID. 79 is our input. Input is 79 because we have the 81 variables are there. We have deleted sale price and ID. That means it is 79 input variables. So our hidden layer, first layer, we can go with 100. Anything above 79. You want, you can give less also. 90 or 80 also can give. I am giving first layer with 100 neurons. Next layer, I am reducing it to neurons, data compression. So like we are passing it through a smaller layer, hoping that some of the features will get compression. We call this as compression. From a larger network, we are pushing them through a smaller network, and then we are widening the network again, so that we can have some compression and some features will be edited. Or if you are not interested in doing that, you can give 100, 100, 100. Let us try with 3 layers of 100 neurons. And then the last layer is 1. Last layer is 1, right? We are predicting only one value, right? Linear, right? And then activation is equal to identity, right? Identity is the linear activation. So NN model is equal to NN dot fit X, Y. NN model dot score X comma Y. See, it predicted with an accuracy R square of 72.489. The R square is 72.489. And another thing is, this is small data, right? So neural networks generally work on large scale data. On small data, their accuracy levels will be affected. This is only how many? 40-60 observations. They need lakhs and millions of data. They are designed to work on terabytes and petabytes of data. So like in cloud, we create large scale pipelines. Pipelines will have 100 GB data, 200 GB data, or large scale data will be there. We'll put them into a container, Kubernetes, Docker, or a container. Then we'll pass that data through a machine learning model. So pipelines can be created, and then you can't pass all 500 GB data in one go, right? You break it into clusters, 50 clusters of 10 GB each. Then each cluster, the pipeline will send the regression algorithm or the classification algorithm. It will run it. Then all the outputs will be aggregated into one place and then shown it as a dashboard to us as a final output. So all the cluster-based environment, cloud works on clusters. Because you can't store 500 GB in one place, right? So it will break it into 10 GB, 50 clusters, or 50 GB, 10 clusters. Your choice. Based on your how many you can rent on. So cloud is pay-per-use. Based on the machines or clusters you are renting, accordingly you will be having your billing done. So based on that, it will do. So if you have a 100-101 network, we got 72.489 as R square. Now I will make the middle layer 50. I will give only 151. Oh, see, we got the conversation, max iterations reached. So we have to add max underscore iter is equal to 1000. See, convergence warning. It is saying stochastic optimizer maximum iterations is and optimization has not converged yet. That means you need to give it more iterations to work upon. Oh, we didn't scale the data. Sorry. $75. See, it increased. By compression, it increased, right? 75.7. But we have not done scaling. We have not done scaling of the data here, right? So now it went up to 75. Let us do one thing. We'll make the network smaller. 80, 50, not 50, 40. 80, 40, 20, and 1. I think we don't need iterations for this smaller network. Oh, again, we got the convergence issue. So max iter is equal to 1000. So 80, 40, 20, 1. So it reduced 73. So earlier one was better, right? 75, we got it. So best would be 100, 50, and then 100, 1. $74. See, compression always works. Compression layer will always work. It will give us a good accuracy. Anybody got a better accuracy than this? Oh, we got 71. Random assignments. No two people will have the same output. Because random assignment of weights, no two people will have the same. That's a 1 in a million thing that people will have same. Random number generator, right? That's a 1 in a million chance. The two people will have the same. $74.94, 115.1. Got it, all of you? So this is how we build a smaller network models. But when you deal with images and large scale data, you have to build large scale models differently. And for image processing, neural network is not that important. The cleaning layers, image cleaning layers will be there. They are very important. Neural network will come in the last. But before that, there are a lot of layers which work on cleaning up the images. They reduce the dimensions of the images, dimensional reductions. They reduce the size of the images without losing any information. After scaling also, the data will be very large. Then what happens is we have to work on those images. We call them as convolution layers or convolution neural networks. In convolution neural networks, the last two layers will be the neural network layers. The first 4 layers or 5 layers will be convolution layers. They work on images. They work on reducing the image size. They work on increasing the sharpness, reducing the blurriness. They work on edge detections. All those things will be done. And once all these layers have performed their job of cleaning the images, and once we have come up with the proper cleaned up data, then we will flatten it into a single vector and then we'll pass it to a neural network. It's a very complicated task which we have to do there. So this is a small data, we can do anything. So, but when you look at large scale data points, first of all, we can't run it on what you call our CPUs. We have to use Google Collaborative. And we have to use only what you call Kaggle. So if you go to Kaggle, there are people who have used in Kaggle, you can see the code, which is done by people who have done this thing. Self-normalizing neural network. So you scale the data, see here, standard scaler. So he has used Keras and TensorFlow. We will use Keras and TensorFlow for large scale image. TensorFlow, Google has developed it. So he is using activation is Selu. Kernel initialization is Licon underscore normal alpha dropout. So he created a model. Wait list, exponential decay. They are used to advanced models. MLP. Some guy has used, but his ranking is very bad, 0.39. So building the MLP model. So he has used 3 layers, 1024 neurons. Activation is value. Normalized input is equal to true. Learning rate 1e minus 3. 1e minus 3 means how much? 0.000. After 3 zeros, 1. Right? And then, which one? Which one? See, we follow the, we computer guys will have this, no? 256, 512, and 102 for the common numbers which the computer guys will remember. Randomly, if you ask anybody, it is 256, 512, or 1024. That is what randomly we pick the numbers because these are the GBs of 60. See, it starts with 64. 64, 128, 256, 512, and 102. That is what we generally do it in. When you ask you to choose a random number for a computer guy, he will go with the bits only, right? So that's what we generally use. So he's generally come up with 1024 units, right? He has given explanation here. See, input layer is set as features. Target is output layer units. So output layer, how many units? Target he has given. Hidden layers, units. Then he has defined the loss. See here. His network has 21,82,145 weights. Morning I built only 9 weight model. This guy is running on 21,82,145 weights. This is the model weights. Total parameters to be tuned is 21,82,145 weights. So he has gone 1024, 1024, 3, and the last layer is 1 predictive layer. And then epochs means 50. One full size of what you call one full process of building the model and backward propagation. We call it as one epoch. Epoch is one cycle of building the neural network and backward propagation. He has gone 50 epochs. Batch size is 1000. That means 1000 data points in one batch. And he has trained the model. So as the epochs increased, his RMSLE reduced. So on 50th epoch, he has got the less error. So you can also try with 1024. Shall we try 1024? 1024, comma 1024, comma 1. He has used activation value. So I'll remove this activation because by default is value, right? By default is value. Sorry. I think it will take time to build. If it gives an error, because already we are giving you too many neurons, right? Maybe iterations will create more problem. It will take more time. Already it is going through a lot of neurons, right? So giving iterations, there is a chance that it might crash. That was model failed. How many neurons has given? So the same, no? 1024. Yeah, it will. It's not a good model actually. That guy also got very bad score. 7M is previous, but compared to decision tree and random forest GP, it's not a good fit model. Minus it's coming in negative one. That means the model is failed.
సాయంత్రం అవుతుంది 204
Yeah, it gave convergence value for me and minus. So 1024 is not a better model. This is the best one. Iterations you have to give, no? Activation what you have given. But such huge difference should not be there. Yeah, it will minus means you have to rework the neurons. All right, so we'll stop it here. We'll continue the next session. So next session we will do some deep learning models. continuation of neural networks. We will work on our neural networks models.
SQL Python.
SQL Python on Friday will do. Let me continue with this. We have anyway started with neural networks, right? Today. So let us continue with this. SQL Python also will do. Oh, see, it's all randomness. There's a lot of randomness involved here. So fine tuning is difficult. That's what. Now it has to be. We have to come up with multiple iterations and multiple times only we'll get the right one. Seven and five. And we don't governance matter. Well, governance not it is Santosh. Tell Santosh. Another thing. From Wednesday and Friday, it will be 2 to 6 only. Not 9 to 1. Because they messed up the whole schedule. It will be 2 to 6 only. Sorry, Wednesday, Friday, Thursday. Thursday I am not free. Thursday I have already classes. Administrative class. Maybe we might have set up a guest lecture or something like that. I don't know. But resume building means you will have the Thursday. So my class will happen Wednesday and Friday, afternoon 2 to 6. Okay? Because the other guys did not agree. They want to go with 9 to 1. So we have to stay with 2 to 6 only. And their batch will end only in the first week of April. Or middle of April only their batch will end. After that, we might go for change. We'll look at 10 to 2 or something like that. Okay? That would be better, right? 10 to 2. So let us see. Then we'll move the batch to 10 to 2. When the new batch, if it comes, it will go to 3 to 7 or 3 to 6, something like that. We'll plan. So Wednesday, my class will be 2 to 6 only. Friday also 2 to 6. Thursday, I am not going to come because I already have scheduled sessions on Thursday. Saturday, we have a class. Saturday also you have a guest lecture, right? So next week, when is Ugadi? April 2nd, Saturday. Okay, you guys want a holiday on Friday? So that's what. Online we can go on Friday. Or if you don't want a session, the next Saturday we have a setup. Next Saturday we'll set up. So you talk to Santosh or Uday is the guy. I think Uday didn't come today. Just inform Santosh, he will inform him. Accordingly, they will set you. So if you don't want an online class on Friday next week, if you are all going home, then next week we'll have it on Saturday. Cover backup class on Saturday. Saturday you can come online or you can come in the classroom sessions. Okay? Or we can do it later on, so backup session anytime. Server disconnected means you have to close it, everything and reopen. Check your antivirus. First thing. If it is still giving problem, uninstall SQL completely and reinstall it again. Connecting to what? I didn't get it. So Microsoft SQL, you are saying server tools, right? Management Studio. I didn't get you. Not getting connected means you are not able to upload the data. That's a different. You have to do it differently. This one. That means you have to reinstall again. Yeah. Reinstall again. Uninstall this thing and reinstall again. And then for data, I think tables. Somewhere we right click, we'll get a table option. I'll tell you how to upload the data. There is a method I forgot actually. Where is that option? Movies.
Database selectors. Right click it's not there. Right click. Database right click it's not there.
Task flow import data. Okay.
Explain the whole process. After you are selecting import data, not source the market.
Data source will be our data is in a DB file, right? SQL DB file, right? That means we have to convert them into Excel files.
convert all the.
And then we have to import them.
I tried like that. So.
Hmm.
After that, different outputs are coming. So in MySQL, they are getting one output, and in SQL Server, they are getting another.
Okay, let me check it once. Okay, I'll get back to you by next session. I will try to run it. Okay.
I converted 70 tables into Excel and I imported. After the different outputs are coming.
Now, different outputs will come because once you convert into Excel, it might have installed an index column for every table. So that will create problem. Let me check once. Huh? Yeah. Main threshold. Which threshold you're talking about? What normalization you're talking about? First of all, text data में ఎట్లా చేస్తారు categorical data మీద numerical లో ఉన్నా కూడా you should not do box plot. 0 1s లో ఉన్నా 0 1 2 3 5 లో ఉన్నా you should not do box plot. It has to be done only on numeric data. How will you do box plot on categorical data which is in numbers 0 1s? If it is data is in 0 1s, how can you do box plot? 0 1s, any binary variable you cannot do box plot. It has to be numeric continuous data only. So if the data is binary or multinomial, you should not do box plot. That's not the right methodology. So you have to understand the data. See, you're jumping and running the models. You're not understanding the theoretical concepts behind. You have to focus on the theory first. For numerical continuous data only, you will build box plots. You will not do it on categorical data or binary data. 0 1 or 0 1 2 3 4 5. Something is there in categoricals. You should not do box plot. Maybe you are trying to do box plot on binary data. If you try to do box plot on binary data, it will be having quartiles problem. Now, where will the quartiles will be calculated? Views, frequency. That's histogram, right? What is that views column? Show me that views column. Value counts of the views column. No, 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 no. It is not a 101, 99, 44. What is that one 94? What is that column? What is the use column? What's column? What is that one? Data dictionary. Where is the data dictionary? Tell me what is the thing is.
Number of times questions has been viewed.
Number of times?
Question has been viewed.
Ah. What is the mean, median? Show me the describe summary.
It's another scientific research.
Minimum is 9. Maximum votes is 5. 5 are considered also 1. Standard deviation is, so this is completely skewed data. See? It's completely skewed data. Outliers are there.
Dependent.
Views in data, not out of outputs. I have declared views. Now, views has lot of data points. See, the standard deviation is 80,950. This is a very large standard deviation. So there is a lot of data which is there in this case.
And the one of the threshold one.
Threshold is
Threshold is equal to 7 meter automatic and 9.
what? Show me the syntax.
Binary everyone is something. Seven binary process.
Level.
Level in company on
Import this from the data preparation.
మన డిపెండెంట్ వర్క్స్ అయినా యూస్ టు threshold చేసి దాన్ని కంటిన్యూస్
This is what answers కదా ఒక పైన ఇవ్వబడింది. ఆన్సర్స్ యొక్క పవర్ బ్యాలెన్స్ వాడాలి. యూస్ ఇక్కడ వాడాలి. ఆన్సర్స్ బ్యాలెన్స్ వాడాలి. యూస్ ఇక్కడ వాడాలి. See, binarization cannot be used on numerical continuous data. Views అనేది numerical continuous data with outliers. ఎందుకంటే చాలా extreme views ఉన్నాయి. దాన్ని మీరు లాగ్ ట్రాన్స్ఫర్మేషన్ చేసినా కూడా I don't think it will correct. So ఆ వ్యూస్ ని ఎట్లా హ్యాండిల్ చేయాలనేది you have to come up. Maybe 30,000 కన్నా ఎక్కువ, అది తక్కువ ఉంటే డ్రాప్ చేసేది. సపోజ్ యూ హ్యావ్ టు ఫైండ్ అవుట్ ఎన్ని ఉన్నాయి, డేటా సైజ్ కి ఎన్ని ఉన్నాయి. ఒకవేళ అవే వ్యూస్ తక్కువలో ఉన్నాయి అనుకోండి, దట్ ఈస్ 100 వ్యూస్ ఉన్నాయి అట్లాగా అవుట్ ఆఫ్ 10,000 డేటా పాయింట్స్ లో, దెన్ యూ కెన్ డ్రాప్. నెంబర్ సైజ్ ఎంత, డేటా సైజ్ then you can download. ఎన్ని ఉన్నాయో చెక్ చేయండి, ఎన్ని ఉన్నాయో నెంబర్ కౌంట్ చేయండి. ఓకే, దట్ ఈస్ ఓకే. అప్వర్డ్స్ అంటారు దాన్ని. తీసుకోవచ్చు, ఎందుకు దాన్ని బైనరీ, అది దాన్ని కేటగిరికల్ వేరియబుల్ గా కన్వర్ట్ చేయొచ్చు, గ్రేటర్ దాన్ లెస్ దాన్ తో. స్కేల్ చేయాలి. వితౌట్ స్కేలింగ్ యూ కాంట్ do. Why? Because the data values are extreme, right? So you have to scale. Scale and just for it. So you have to study what they are doing, why they are doing. Then only you will understand. Binarizer is different. Binarizer, we don't use it generally. We stop using binarizers now because it will create a problem in data. Adi data corrupt chestundi. Encoder vaadtam మేము, binarizers వాడట్లేదు. అవును, అదే కదా నేను చెప్పాను మీకు. ప్రతి దాన్ని మీరు ఎక్స్ప్లెయిన్ చేయాలి, ఆ స్టెప్ ఎందుకు చేస్తున్నారు ఏంటి. ఎవ్రీథింగ్ యూ హావ్ టు ఎక్స్ప్లెయిన్. దట్స్ వాట్ ఐ బీన్ టెలింగ్ యూ గైస్. Code running is not the thing. You have to write explanation. Why are you doing that step? What is the importance of the step? Everything has to be written. Like how I write in the notebooks, you have to write it like that. Which one? Yeah, I have not checked it. I was busy with the bits evaluation, so maybe this weekend I will check. You have to write. You have to write interpretation, analysis, inferences, everything. Otherwise, GitHub professors, they'll simply say you cut copied from some source. They'll simply say that. And if you are not able to explain the code, what you have written, they'll outrightly disqualify you in things. Nowadays, they are simply asking you to see. It happened, one of the earlier batch students. I have been telling him to maintain his GitHub properly. He cut copied some code from someplace and written it. The recruiter told, share your screen, import the data set, and show me how you have imputed the missing values. That fellow didn't do the imputation process, understand it correctly. He was not able to explain. Then within 2 minutes, the interview was over. See, you have to write interpretation, analysis, the process which you followed. All these things are very important. without doing those things, you cannot be selected. Your GitHub profile will not be shortlisted, your resume will not be shortlisted. రీడ్ మీ కూడా రాస్తున్నారు చాలా మంది. రీడ్ మీలో డీటెయిల్ గా రాస్తారు ఏమేమి చేశారు, ఏం ప్రాసెస్ చేశారు, ఎవ్రీథింగ్ దే విల్ రైట్ ఇట్. ఆర్ జనరలీ హియర్ ఐఎమ్ నాట్, మీరు ఇంట్రెస్ట్ లేదు కానీ మాకు academics లో ఏంటంటే దే హావ్ టు సబ్మిట్ ప్రాజెక్ట్ రిపోర్ట్స్. సో దే హావ్ టు రైట్ ఇంటర్ప్రిటేషన్, అనాలిసిస్, ఎవ్రీథింగ్ హ్యాస్ టు బి రిటర్న్. అదర్వైజ్ we will disqualify them and there should not be plagiarism. Plagiarism చెప్పోట్ చేస్తాం. బిట్స్ వాళ్ళది అందులో ఏంటంటే వాళ్ళు రిపోర్ట్స్ రాయాలి ప్లస్ అది ప్లేగరిజం చెక్ అవుతుంది ఆటోమేటిక్. ఎక్కడి నుంచి అది కాపీ చేస్తే ఇమీడియట్ గా అది సాఫ్ట్వేర్ ఐడెంటిఫై చేస్తుంది, మేము 0 ఇచ్చేస్తాం అవుట్ రైట్. అట్లా ఉంటుంది. సో మీరు ఏంటంటే యూ హ్యావ్ టు రైట్ ఆన్ యువర్ ఓన్, అండర్స్టాండ్ థింగ్స్ ఆన్ యువర్ ఓన్. మీ దగ్గర ఏంటంటే మీరు యూఆర్ రన్నింగ్ ద కోడ్స్ బట్ యూఆర్ నాట్ అండర్స్టాండింగ్ వాట్ ఇట్ ఈస్ వాట్. అది ప్రాబ్లం. రన్నింగ్ కోడ్స్ ఇంపార్టెంట్ కాదు, అక్కడ ఎందుకు చేస్తున్నారు ఆ స్టెప్, దానివల్ల ఏం జరుగుతుంది, దానివల్ల యూటిలిటీ ఏంటి. మీకు ఇంకో చెప్తాను, చాలా మంది అన్నెసెసరీ స్టెప్స్ పెడతారు బికాస్ దే డోంట్ నో, దే కాపీడ్ ఇట్ ఫ్రమ్ సంబడి ఎల్స్, దే డోంట్ నో. వాడు అడిగాడు ఆ సేమ్ పర్సన్ ని, ఓకే నువ్వు ఈ స్టెప్ చేసావు, ఇది ఎందుకు చేసావు, ఏం స్టెప్ అంటే హీ హాస్ యూస్డ్ గెట్ డమ్మీస్. అతనికి తెలియదు గెట్ డమ్మీస్ అంటే ఏంటో తెలియదు. Then he said, mistakenly I have run get dummies because I should have done label encoder. అది తప్ప ఆన్సర్. గెట్ డమ్మీస్ లేబుల్ ఎన్కోడర్ సేమ్, కాకపోతే మాది కాలమ్స్ క్రియేట్ చేస్తుంది, బైనరీ ఎన్కోడింగ్ చేస్తుంది, ఇది సేమ్ థింగ్. సో దట్ గై సింప్లీ సెడ్ యూ హావ్ కాపీడ్. ఇక్కడ హెచ్ఆర్ అదే వచ్చింది, కాపీ పేస్ట్ చేసేసి పంపిస్తే వీ డోంట్ యాక్సెప్ట్ అని. అవును అడుగుతారు, ఎందుకంటే ఇట్స్ డిస్టెన్స్ బేస్డ్ ఇంప్యూటర్ విచ్ ఇస్ అవైలబుల్ ఇన్ పైథాన్. అది ఎందుకు వాడుతున్నాము అంటే మనము, మీరు చెప్పండి, ఫ్యాకల్టీ టోల్ దట్ ఈస్ ఓన్లీ అవైలబుల్ ఇన్ పైథాన్, సో వీఆర్ యూజింగ్ ఇట్ టు అండర్స్టాండ్ ది ఇంప్యూటర్ ప్రాసెస్. అదర్వైజ్ మాన్యువల్. Advanced KNN imputer uses the nearest 5 rows and then imputes. Simple imputer mean, median, mode same. Manual imputation, manual imputation automate చేస్తారు. ఎర్రర్స్ అంటే